A good idea to start these questions by sketching the graphs. Okay, so we will do that. So the first one's log e x plus 1, so that means that we've been shifted 1 unit to the left. There's no reflections, and that's going to be your domain. So, okay, so if I put that 0 log e1, so it's going to go through like that. Okay, so that's the graph of f. Okay, and then here we'll do g, so that's sine squared x. So what you need to realize is when you have, so if you don't have your calculator, you know it's this, it's sine x all squared, that's what it means. So if you think about the graph here of sine x, it's like this. So basically what's going to happen is all the values will be squared. So all the positive values will be squared, but it will still be that shape. And then what will happen here is we'll square these values. Instead of minus 1 here, you know, it's going to be 1. So what's going to happen is it's going to come up with this. And this is what sine squared x will look like. Okay, so here what we want to do is do our domain and range. Okay, so we'll make up a little table for a domain and range here. So the domain of f is going to be what's stated here, minus 1 to infinity. For g, it's going to be r. The range is going to be r from a logarithm graph. And here, you know, it's not going to go above 1, so this is actually going to go, the range will be 0 to 1. So that's the first thing I do. Now looking at question, we want to find the rule of h. So h of x is f of g of x, so we know that f of x is log e x plus 1, and we want to do f of g of x, so we're doing f of sine squared x. So this is going to go log e sine squared x plus 1. So that is what h of x is going to be. Now, looking at the next question, what we want to do is find out the domain and range. So what I'm going to do is look at this little sketch. It'll help the understanding. So f of g of x means that g of x is the first function performed. And then we'll then perform f on that function, and that will give us f of g of x. So therefore, what we're doing is we're starting with the domain of g for the first part of the composite function. That will give us the range of g. Then the domain of f will then map to the range of f of g of x. This is the important bit here, which will decide whether it exists or not. So looking at our table here, we know that the domain of g is minus 1 to infinity. The range of g, I wrote that wrong. Let's do that again. So the domain of g is r. And then the range of g is 0 to 1. And the domain of f is minus 1 to infinity. So we'll see here, there's no values here in the range of g that are not going to work for the function f. So therefore it's going to exist. So that's all good. So thinking about that then, so therefore the domain, okay, so that means that the domain of h of x, because it does exist, is just going to be the domain of the inside function, which in this case is g of x, so that's going to be r. The range, however, a little bit more difficult. We just need to think of it as, these are the values that you're getting out of the function g. So these are the only values that you're going to use then for the second part f. So this domain here is going to be reduced to just values between 0 and 1. So what we want to do is go and look at the graph for f and see and restrict that domain. So you see here, if we look at f, it's only going to exist between 0 and 1 now, because that's only going to be the relevant x values. So this is going to be how we're going to work out the range now. So this value here, if we put in 0, we know that that's 0, 0. And then if we put in 1 here, this is going to be ln 2. So therefore we can see that the range of the composite function is going to be between 0 and natural log of 2. So the range of h of x is going to be from 0 to ln 2, natural logarithm of 2.